Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope all of you are doing great, having a good time. Yes. So people, you can first of all let me know in the chats if I'm audible and visible to everyone. Hello Ishpreet, hi Anirudh, hello Ashwarya, hi Aisha, hello Sanjay, hello Sana, hi Roshni, hello Anadura, hi Meenakshi. Welcome back all my people, welcome back. Just give me some green signal first of all from the chat so that I'll get to know that I'm audible and visible to you. Just let me fix the things first. We'll be starting here. All right. I'm doing good, Ashwarya. My day was good. What about yours? Perfect. I'm doing good, Aisha. I'm doing good. How are you? All right, people. So if you remember, in the last session, we talked about the basics of the general organic chemistry, right? In the last session, we talked about the stability of the charges on different elements, right? We saw exactly how to compare the stability of the charges on different elements belonging to the same period or the same group, right? Well, what we are going to do in the tonight's session, we will be first of all starting with some questions, with some good questions, right? Once we are done with the questions, then we will come to the actual topic, and the actual topic is written on the screen, which is what we call as inductive effect, right? What the first electron displacement effect, which we are going to study in the tonight's session, okay? So before starting the session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. Well people, my name is Wassim and I'm your chemistry master teacher right here on this JEE Enthuse channel, right? Well, the ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? So before starting the session, you guys are going to let me know in the chats if you all are super duper excited about the session, right? Just let me know in the chats first if you all are super duper excited about the tonight's session as well, okay? Let me know fast. Well, I can see a lot of fire symbols coming up. That's wonderful. That's great. All right. Perfect, guys. So let's get going then. Let's get started with the tonight's session, okay? Let's try to do certain questions, but before doing the questions, let me give you some basic concepts first of all, okay? Have a look. See, guys. Let's assume I have got an acid which I represent with HA. Let's say it is a general acid, for example, right? Let's say it is one general acid, okay? As per one of the definition of acids, anything which on dissolving in water gives away H positive ions, right, furnishes H positive ions, we call that species as the acid, right? So first thing, I'm assuming this HA as the acid, and if I'll put this HA into water, it is going to get dissociated as H positive aqueous plus A negative aqueous, right? I'm considering this HA to be an acid, right? Do remember, an acid after donating H positive, right? After donating H positive, this acid is getting converted into A negative, right? After donating H positive, this acid is getting converted into A negative, right? This A negative is what I will be calling as the conjugate base of this acid which I've taken into consideration, right? So first of all, this acid, after donating H positive, it gets converted into A negative. A negative is what I will be calling as the conjugate base of this acid HA over here, right? Do remember, strength of the acid, right? Strength of the acid depends on the stability of the conjugate base. This is one important point from which we will be doing a lot of questions. Strength of acid, it is it depends on basically the stability of the conjugate base. Do you remember? More the stability of the conjugate base, more the stability of the conjugate base, more is going to be the strength of the acid. More the strength of the acid, more is going to be the dissociation constant of this acid. More is going to be its Ka value. Okay, this is one simplest statement which I want every one of you to take a note of, right? What it's going to be, an acid after the donation of H positive, it gets converted into A negative. This A negative is what I call as conjugate base. Strength of acid depends on the stability of the conjugate base. More stable the conjugate base, stronger the acid, more the value of Ka. As simple as that, okay? I'm going to use this concept and we'll be doing certain questions based on the acidic strength, right? Let's get started with the first question, with a series of questions, I must say, which are on the screen. Have a look. Arrange the following in acidic strength. Arrange the following in as per as their acidic strength. You need to see which one among the two has got more acidic strength. Which one among the two has got more Ka value, correct? That's what I need to check. And how do I check it? Have a look. As I told you, strength of acid, it depends on the stability of conjugate base of the acid, right? So first of all, this acid, after the donation of H positive, it gets converted into RO negative, right? This RSH, after the donation of H positive, it gets converted into RS negative. So these are basically the conjugate bases. These are the conjugate bases of these respective acids. I got the conjugate bases of these acids. Point number one. Point number two. Compare the stability of these conjugate bases. Wherever conjugate base is going to be more stable, that acid is only going to be stronger, right? That acid will have more acidic strength, as simple as that. See, over here we have got the negative charge on oxygen, and right here we have got the negative charge on sulfur. Oxygen and sulfur, they belong to same group, and whenever you need to compare the stability of the charges present on the elements which belong to same group, at that point of time, volume charge density comes into the play, right? If you remember, volume charge density, which we discussed in the last session, right? Volume charge density, it depends on the charge present on species, and at the same time, it depends on the size of the species as well, right? Since the charge present on both the species is the same, now compare their size. Sulfur has got more size, so over here, it will have less volume charge density. Less the volume charge density, more is going to be the stability. So I must say stability of this conjugate base. Stability of this conjugate base is more, right? And more the stability of the conjugate base, more is going to be the acidic strength. So this is going to be the order. This is going to be the acidic strength order, right? Right, my dear people? Absolutely. Let's have a look on one more question. Compare the acidic strength of the following. Have a look. Take H positive out from here, there will be negative charge. Take H positive out from here, there will be a negative charge on nitrogen. Take H positive out, negative charge on oxygen. Take H positive out, negative charge on fluorine. Now, I got the conjugate bases. Conjugate base of CH4 is CH3 negative. Conjugate base of NH3 is NH2 negative. H2O is OH negative. HF is F negative. I got the conjugate bases. Compare the stability of the conjugate bases. Over here, we have got negative charge on carbon, negative charge on nitrogen, negative charge on oxygen, negative charge on fluorine, right? So these elements, carbon, nitrogen, oxygen and fluorine, they belong to same period, right? And along the period, electronegativity dominates, if you remember, correct? Negative charge is more stable on more electronegative element, okay? So where is the conjugate base? Which conjugate base is going to be more stable? Fluorine being the most electronegative element among all these carbon, nitrogen, oxygen, fluorine, right? Fluorine being most electronegative. Negative charge is more stable on more electronegative element. Negative charge is more stable on fluorine, right? So conjugate base of HF is more stable. If conjugate base of HF is more stable, then definitely this is going to be the acidic strength order. Whatever is going to be the order of the stability of the conjugate base, same is going to be the order of the acidic strength of these acids, right? Simple. Now we have got H2O, H2S. Just make the conjugate base of this water. Take H positive out, it's going to become OH negative, right? Similarly, take H positive out, it's going to become HS negative. Negative charge on oxygen, negative charge on sulfur. These are the conjugate bases of these two acids, okay? Right? Compare the stability. Negative charge on sulfur, negative charge on oxygen. Oxygen and sulfur, they belong to same group. And in the group, volume charge density comes into play. More size, less volume charge density, more stability. So this is going to be the stability of the conjugate basis, right? So the same is going to be the acidic strength order, as simple as that, right? Right, people? Absolutely. Similarly, if you talk about this one, have a look. First of all, take H positive out from here. There'll be negative charge on carbon. Take H positive out from here, negative charge on this carbon. Take H positive out from here, negative charge on this carbon, right? This is single bonded carbon carrying negative charge, double bonded carbon carrying negative charge, triple bonded carbon carrying negative charge. If you remember, triple bonded carbon has got more S character, more electronegativity. Negative charge is more stable on more electronegative element, right? Yes. So I think the question is done, right? So, or let me make it for you like this. Let me make their conjugate basis first of all. This is going to be CH3, this is going to be CH2 with a negative charge, just take an H positive out. Similarly, take H positive out from here, it's going to be CH with a negative charge. Take H positive out from here, it's going to be CH, triple bond C with a negative charge. These are the conjugate bases of these acids, right? Where is the negative charge more stable? Negative charge is more stable over here. So what is going to be the order of the stability of the conjugate bases? This is the order of the stability of the conjugate bases, and whatever is going to be the order of stability of conjugate bases, same is going to be the order of their acidic strengths, right? Simple? Absolutely. If you talk about the last one, right? If you talk about the last one, understand one thing first of all. This is first of all sp hybridized carbon, right? This nitrogen has got the lone pair. This is sp3 hybridized nitrogen. This is sp hybridized carbon. This is sp3 hybridized nitrogen. Okay. Normally, when I ask you, is carbon or nitrogen, which one is more electronegative? Normally, under normal conditions, you will say nitrogen is more electronegative than carbon. But do remember, electronegativity of sp hybridized carbon is always more than that of the electronegativity of sp3 hybridized nitrogen, right? Do take a note of this point. Electronegativity of sp hybridized carbon is more than that of electronegativity of sp3 hybridized nitrogen. Okay, now let's compare the acidic strength. Just take H positive out from here. If you take H positive out, it's going to be R, this is going to be C, right? Okay, and this is going to be triple bond, this is going to be C with a negative charge, right? Oh, wait, this is not R, this H basically. This is H, okay? This H. Right? Take H positive out from here, it becomes NH2 with a negative charge on nitrogen, right? sp hybridized carbon carrying negative charge. sp3 hybridized nitrogen carrying negative charge. Which one is more electronegative? I'll say this carbon is more electronegative. Negative charge is more stable on more electronegative element. So this is the stability order. If this is the stability order, same is going to be the acidic strength order, right? Perfect. This is very, very, very simple. I'm sure every single thing is clear to you, right? So if all these questions are clear to you, you guys can let me know in the chats if you want me to start with the inductive effect right now. Let me know first in the chats if every single thing is clear, my dear people. Fast. Grant, IIT Bombay currently in CSC is the best. And of course, IIT Madras. Okay, so let's get started then. Let's see what exactly this inductive effect is all about, right? What this inductive effect is all about. First of all, I'm going to read its definition. Then I'll make you understand what this inductive effect is all about. Have a look exactly what it is, okay? See guys, whenever any atom or group of atoms is bonded to a carbon chain, the entire carbon chain becomes partially polarized. The entire chain becomes partially polarized because of sigma electron transmission, and this effect of the sigma electron transmission is what we called as inductive effect. Now the point is, what is meant by this? Have a look. Let's try to understand this. Let's say over here I'm taking a carbon chain, right? Over here, for example, this is the carbon chain which I've taken, and this carbon is attached with hydrogen, for example, right? In the carbon chain, everywhere you have got the sigma bonds. There is no pi bond in between. Everywhere you have got a sigma bond. So this is the carbon chain, and this carbon is attached with hydrogen over here, right? Now, for example, I'm going to replace this hydrogen with some atom or some group. I'm going to replace the hydrogen 1, 2, 3, 4, right? Now what am I going to do? I'm replacing this hydrogen with some atom or a group X, right? I've replaced hydrogen with X. Similarly, I'm going to replace this hydrogen with some atom Y. Right? I've replaced the hydrogen with some atom Y. Atom or group of atoms Y, right? That's what I've done. Over here, we had hydrogen attached with the carbon. Now I'm replacing this hydrogen with X, and over here, I'm replacing this hydrogen with Y, right? Let's assume, over here, first of all, everywhere in the chain, you have got the sigma bonds. So in the chain, you have got sigma electron density, right? In the chain, you have got sigma electron density, right? Let's say the sigma electron density in this chain particularly, is equal to A. This A represents the sigma electron density in the chain. Let's assume the sigma electron density in the chain is represented by B. Let's assume the sigma electron density in this chain is represented by C, right? Okay. Now I'm giving you certain conditions. If for example, A is less than B, if A is less than B, or let's not say it like this, if I'll say for example, if B is less than A, if B is less than A, that means if sigma electron density in this chain is less than that of sigma electron density in this chain, what can we conclude from that? What can we conclude? See, the sigma electron density in this chain was A when over here hydrogen was attached. The sigma electron density over here is represented by B when X was attached, right? Now I'm assuming, this is my first case, if B is less than A, that means if sigma electron density in the chain over here is less than that of sigma electron density in this chain, right? What can we conclude? Can we conclude something like this? When hydrogen was replaced by X, what this X did, this X pulled the sigma electron density towards itself. This X pulled the sigma electron density towards itself, due to which sigma electron density in this chain decreased. And that's why sigma electron density in this chain came out to be less than that of sigma electron density in this chain, right? Okay, that's something which I can conclude from here. I can conclude when H was replaced by X, and I'm saying B is less than A. Sigma electron density in this chain is less than that of sigma electron density in this chain. What can we conclude? I can conclude something like this. I can say this X has dragged the sigma electron density towards itself, and if this X is dragging the sigma electron density towards itself, I must say this X would have got delta negative, this carbon would have got delta positive, even this carbon would have got delta positive, this carbon would have got delta positive, etc., etc. That means this X is dragging sigma electron density towards itself. This X has dragged the sigma electron density towards itself, right? Okay. Perfect. So what this X did, since it dragged, it pulled the sigma electron density towards itself. Right? It pulled the sigma electron density towards itself, due to which this chain got partially polarized, right? Charges came on the carbon atoms. Okay? So this chain got partially polarized when hydrogen was replaced by some atom or group of atoms, X. This chain got partially polarized. And this inducement of partial polar character, when hydrogen will be replaced by some atom or group of atoms, this inducement of partial polar character in the chain, this effect is what we call as the inductive effect. This effect is something which we call as inductive effect, right? And do remember, that atom or group of atoms, which drags the electron density from the chain, which decreases the electron density in the chain, that atom or group of atoms, which decreases the sigma electron density in the chain, we say this atom or group of atoms shows minus I effect, right? It decreases the sigma electron density in the chain. Okay? This was the first case. Second case, have a look. I'm assuming if C is greater than A, this is the second thing which I'm assuming. If C is greater than A, what is C? C is the sigma electron density in this chain. A was sigma electron density in this chain. What I did basically, I replaced hydrogen with this Y. And later on I realized sigma electron density in this chain was more than that of sigma electron density in this chain, right? What can we conclude? I can conclude when hydrogen is replaced by Y, sigma electron density in the chain increased, which is only possible if this Y would have pushed the sigma electron density towards the chain, right? if this Y would have pushed the sigma electron density towards the chain, due to which Y would have got delta positive and this carbon would have got delta negative, this delta negative, this delta negative, right? And any atom or group which increases the sigma electron density in the chain, we say that atom or group shows plus I effect. So this group or atom, it is showing the plus I effect, right? Perfect. So in short, when hydrogen is replaced by an atom or group of atoms, a partial polar character, right? Yes, the carbon chain becomes partially polarized. And due to the inducement of this partial polar character in the chain, right, by the presence of atom, right, or a group of atoms, we call this effect as the inductive effect. Right, people? Got it? Is that clear? You got to know exactly what this inductive effect is all about? Simple? Okay, so whenever an atom or group of atoms is bonded to the carbon chain, the entire chain becomes partially polarized, right? Because of the sigma electron transmission, right? And this effect of the inducement of the partial polar character in the bond, right, due to the transmission of sigma electron density, right? This effect is what we call as the inductive effect. I'm sure this is clear to everyone. Yeah? Perfect. Now there are certain things which you need to know. If I ask you, this inductive effect is measured with respect to which atom? You'll say it is measured with respect to hydrogen. You replace hydrogen with X, then you replace hydrogen with Y, right? This inductive effect, it's measured with respect to hydrogen. This hydrogen is taken as a reference in case of the inductive effect, right? Okay, and any atom or group which decreases the sigma electron density in the chain, we say that atom or group shows minus I effect. And any atom or group which increases the sigma electron density in the chain, we say that atom or group of atoms shows plus I effect, right? Prashant bro, look at the name of the channel. It is the English channel, okay? This is the English channel, bro. This is the English channel. I'm not supposed to talk in Hindi, right? Well, we have got one more channel, Vedantu JEE, okay? That is the Hindi channel. You can check it out there, yeah? Medico, you can go there, bro. Okay, I think you're not familiar with the channel. The name of the channel is Vedantu JEE Enthuse English, right? So this understood. You're not supposed to say this. Anyways, it is measured with respect to hydrogen atom, right? This is something which is understood. That group of atom which decreases the sigma electron density in the chain, we say it shows minus I effect. And that group or atom which decreases the sigma electron density, which increases the sigma electron density in the chain, right? We say it shows plus I effect, right? So that group which shows plus I effect, it increases the sigma electron density in the chain, and that group which shows minus I effect, it decreases the sigma electron density in the chain. That's completely understood, right? We have discussed it. Yes? Okay. And at the same time, we say plus I and minus I effects, these are relative to each other. What does it mean? We say plus I and minus I effects, these are relative to each other. What it means exactly? Let me make you understand this statement through an example. See guys, have a look. First of all, if I ask you, what is the hybridization of this carbon? You will say it is making 2 sigma bonds. So hybridization of this carbon is sp. If I ask you, what about the hybridization of this carbon? You will say 1, 2, and 1 with hydrogen. So 3 sigma bonds, it's sp2, right? S character is more over here. More the S character, more the electronegative. So this carbon is more electronegative than that of this carbon. If this carbon is more electronegative, it's going to drag the sigma electrons towards itself, right? Due to which it gets delta negative and this gets delta positive, right? If I talk about this group, in particular, right? If I talk about this group in particular, can I say this group is dragging the sigma electrons, right, towards itself? Okay. So can I say this group is over here showing minus I effect? Yes, it's showing minus I. What about this group? Can I say this group is pushing the sigma electron density over here, right? So can I say this group is showing plus I effect? So I must say this group is showing minus I with respect to this group, and this group is showing plus I with respect to this group, right? So I can clearly say plus I and minus I, these are relative towards each other, right? Simple again. Similarly, if you talk about this one, if you talk about this carbon and this carbon, which carbon is more electronegative? I must say this carbon is more electronegative. We have discussed the electronegativity of this carbon in the last session, if you remember, right? This carbon is more electronegative. So this carbon is going to drag the sigma electrons towards itself, which gets delta negative, and this gets delta positive. So if I talk about this group in particular, can I say this group is pulling sigma electrons towards itself? So this group is showing minus I effect. And this group in particular, it is pushing the sigma electrons, it is pushing the sigma electron density towards this group. So it is showing plus I effect, right? So plus I and minus I, can I say these are related to each other? This group is showing minus I with respect to this group. This group is showing plus I with respect to this group. So do remember plus I and minus I, these are two relative terms, right? Okay, do remember this as well. It's again important, right? Do remember one more thing. There are a few more things which you need to remember. All the cationic groups, any group which contains positive charge on it, any group which contains positive charge on it is called as cationic group, right? And all the cationic groups are going to show minus I effect. All the cationic groups, when attached to the carbon chain, they decreases the sigma electron density in the carbon chain. They show minus I effect. All the cationic groups are going to show minus I effect. And do remember, minus I power of cationic group is always greater than minus I power of the neutral group. Do remember this thing as well. Minus I power of the cationic group is always greater than minus I power of the neutral group, right? So that's the second statement. Minus I power of the cationic group is always greater than that of minus I power of the neutral group, right? If you talk about the group 17 elements, halogens, they are electronegative. They are more electronegative compared to the rest of the elements, right? Yes, halogens are more electronegative elements basically, okay? So when the halogens are attached with the carbon chain, they decrease the sigma electron density in the carbon chain, right? So all the halogens, they show minus I effect, right? They show minus I effect. It's simple. All the halogens, they are going to show minus I effect, right? Because the electronegativity of halogens is definitely greater than that of carbon. So when any halogen will be attached with a carbon chain, halogen is going to attract the sigma electron density towards itself, right? Due to which the sigma electron density in the chain gets decreased, and any group which decreases the sigma electron density in the chain, we say that group shows minus I effect, right? I'm again sure this will be clear to you, right? Groups like OH, NH2, NO2, CN, C double bond O, C double bond OH, C double bond OR, right? All these groups, they are going to show minus I effect. Why they show minus I effect? Have a look. Have a look exactly. See guys, it's simple. Let's assume this group is attached with a carbon chain. This is a carbon chain, for example, which contains only the sigma bonds, right? And over here, OH is attached. Over here, OH is attached, right? So oxygen is basically directly attached with carbon, correct? Oxygen is more electronegative. It's going to drag the sigma electron density towards itself, due to which it gets delta negative, this gets delta positive, this gets delta positive, this gets delta positive, right? And as you move far from this oxygen, as you move far from this group, the intensity of the positive charge on the carbon decreases. The intensity of the positive charge on the carbon decreases, right? That's why we do not take the inductive effect after the third carbon. We take the effect, we take this inductive effect till the third carbon. After this, we do not consider this effect, right? Yes? So, due to more electronegativity, I must say this group is pulling the sigma electrons towards itself, right? Which, that means this group is decreasing the sigma electron density in the chain, right? And any group which decreases the sigma electron density in the chain, we say that group shows minus I effect, right? Similarly, you have got NH2. When this nitrogen will be attached with a carbon chain, right? It's again going to drag the sigma electrons towards itself. So again minus I. When this nitrogen, again minus I. This is Cn, correct? This is basically C triple bond N. This is basically C triple bond N. When it will be attached with the carbon chain, let's say this is the carbon chain. Let's say this is the carbon chain, right? This is the carbon chain. This carbon is first of all sp hybridized. This carbon is sp2 hybridized. This is sp, this is sp2. More is the S character for this carbon. More S character means more electronegativity. So electronegativity of this carbon is more. If electronegativity of this carbon is more, it's going to drag the sigma electron density towards itself, due to which this CN group again shows minus I effect, right? Same is the case for everyone over here, right? When this group is attached with a carbon chain, what happens? Let's say this is the carbon chain over here, right? Let's say this is the carbon chain over here, and I have attached this group with the carbon chain. First of all, among carbon and oxygen, which one is more electronegative? Oxygen. So oxygen will have delta negative on it, carbon will have delta positive on it, right? Okay, as simple as that. See, this carbon is neutral over here. This carbon is delta positive. So electronegativity of this carbon is more, right? Due to the delta positive over here. Positive charge on an element makes it more electronegative. So I must say this carbon is more electronegative than that of this carbon. Due to which this carbon, this group is going to attract the sigma electron density towards it, which makes this group to show minus I, right? Same is the reason for this. It shows minus I. Same for this, minus I, same for this, minus I. Because everywhere carbon is having delta positive, because everywhere carbon is attached with the more electronegative element like oxygen, right? Right, people? Perfect. Let's move on and talk about a few more interesting things. Do remember all the anionic groups, any group which contains negative charge on it, that's what we call as the anionic group, right? And all the anionic groups, they are going to increase the sigma electron density in the carbon chain when attached with the carbon chain. So all the anionic groups, they are going to show plus I effect, right? And do remember, plus I power of the anionic group is always greater than that of the plus I power of the neutral group, right? Yes, do remove this thing as well, okay? Plus I power of the anionic group is always greater than that of plus I power of the neutral group, right? Do remove this thing as well, it's very important. Okay, plus I power of the anionic group is always greater than plus I power of the neutral group, right? All alkyl groups, they show plus I effect. All the alkyl groups show plus I effect, right? For example, let me make it understand. Let's say this is the alkyl group. This is hydrogen, this is hydrogen, this is hydrogen. This is the alkyl group and it is attached with the carbon chain, for example. Let's say this is the carbon chain which I'm talking about, okay? This alkyl group is attached with the carbon chain, right? If I ask you, among carbon and hydrogen, which one is more electronegative? Which one is more electronegative? You will say carbon is more electronegative. If carbon is more electronegative, it will attract the bonded pair of electron towards itself. So delta negative on this carbon due to this bond. Similarly, delta negative on the same carbon due to this bond. Delta negative on this carbon due to this bond, right? So this carbon attains overall negative charge, right? Between these two carbon atoms, there's a bond. So that means there's a bonded pair over here, right? Can I say there'll be repulsions between the negative charge and this bonded pair? If there are repulsions between this negative charge and the bonded pair, can I say this negative charge is going to push this sigma, this negative charge, it's going to push this bonded pair of electron towards this carbon, due to which sigma electron density towards the chain is increasing. If sigma electron density towards the chain is increasing, I must say this group is basically increasing the sigma electron density in the chain, and any group which increases the sigma electron density in the chain, we say that group shows the plus I effect. So this CH3, this alkyl group over here, right, it simply shows plus I effect, yeah? As simple as that, right? Okay. Do remember one more thing. Plus I power is directly proportional to number of branching at the free valent carbon. Number of branching at the free valent carbon, correct? Just a second. Okay, this is this one. Right, have a look. These are the two groups which I've taken, right? These are the two groups which I've taken. Let's say this group is attached with the carbon chain. This is the carbon chain which I'm representing. Even this group is attached with the carbon chain, correct? That particular carbon which is attached with the carbon chain, that's called as free valent carbon. So this is free valent carbon. This carbon is attached to the carbon chain, so this again free valent carbon. Okay? Plus I power is directly proportional. Plus I power is directly proportional to the branching at the free valent carbon. Right? So at this free valent carbon, this is one branch, this is the second branch. At this free valent carbon, 1, 2, 3. And all these three individually, they show plus I. This will show plus I, this will show plus I, this will show plus I, right? So basically, they will increase the sigma electron density towards this carbon, due to which there will be negative charge on this carbon, right? Even there will be negative charge on this carbon as well, delta negative on this carbon as well. But the magnitude of delta negative will be more here, right? Because 3 electron donating groups are attached on the 3 sides. Yes? So negative charge magnitude on this carbon is more. If negative charge magnitude on this carbon is more, can I say more repulsions will take place between this negative charge and this electron pair, due to which sigma electron density gets pushed towards the carbon. So I'll say overall plus I power of this will be more, right? Isn't it simple? Isn't it simple, my dear people? Got it? I want you guys to remember all this, okay? Right? So plus I is directly proportional to the number of branching at the free valent carbon, right? Yes? More the branches, right? Which increase the electron density towards this free valent carbon, right? More is going to be the plus I power of the complete group. Do take a note of this. Correct? If branching is same, then plus I power is directly proportional to number of carbon atoms, right? If branching is same, then definitely, let me make you understand it like this. See, let's say this is the carbon chain. With this carbon chain, this is the carbon. With this carbon, this is, for example, CH3. This is CH3, correct? And over here, I'm writing it like this. This is CH, right? This is CH, CH3, correct? Similarly, I'm taking one more. This is the carbon chain. Right? With this carbon chain, this is, for example, CH2, this is CH3, this is CH2, and this is basically CH, correct? Have a look first of all. This carbon is attached with the carbon chain, so it's a free valent carbon. This carbon is attached with the carbon chain, so this is a free valent carbon. Is the branching same? Two branches? Absolutely two branches, right? If the branching is same, then which one among the two will show more plus I power, right? When the branching is same, then you decide the plus I power on the basis of the number of carbon atoms. Number of carbon atoms in this chain is greater, right? So this complete group will show more plus I power as compared to this complete group, right? Do take a note of this thing as well. This again important, right? If branching is same, then plus I power is directly proportional to the number of carbon atoms, right? Okay. If you talk about the isotopes of hydrogen, right? Protium, deuterium, tritium, right? All these are going to show plus I effect. All these are going to show plus I effect, right? All these are going to show plus I effect. And do remember, plus I power of tritium is more than that of deuterium, which is more than that of protium, right? Plus I power of tritium is more than that of deuterium, which is more than that of protium. Do take a note of this thing as well. Okay. Arrange the following according to minus I power. Arrange the following according to minus I power. First of all, we need to arrange these four on the basis of their minus I power, right? When this will be attached with the carbon chain, I'm assuming this is attached with the carbon chain, this is attached with the carbon chain, this iodine is attached with the carbon chain, right? Fluorine being more electronegative, it's going to drag the sigma electrons, it's going to pull the sigma electrons maximum towards itself, right? So this fluorine is going to show more minus I power as compared to the rest, right? Fluorine attached with a chain, right? Oxygen attached with a chain, nitrogen attached with a chain. Fluorine being more electronegative, it's going to drag the sigma electrons towards itself. So this fluorine shows more minus I as compared to the rest, right? Simple. NH3 positive NO2, cationic group, neutral group. Minus I power of cationic group is always greater than minus I power of neutral group, right? Oxygen attached with carbon chain, okay? Nitrogen attached with the carbon chain. Oxygen being more electronegative will attract the sigma electrons more towards itself, due to which it shows more minus I power, right? What about this one? Triple bonded carbon attached with the chain, right? Double bonded carbon attached with the chain. Single bonded carbon attached with the chain, right? Can I say electronegativity of this carbon is more as compared to this carbon, as compared to this carbon? If electronegativity of this carbon is more, this carbon is going to attract, this group is going to attract more sigma electrons towards itself, so it will show more minus I power. This is the order. Can you let me know fast in the chat if it's clear? Let me know fast. No, Tanuja, no, not in 12th. Perfect. So let's move on. Arrange the following in minus I power only. Okay. You need to arrange them on the basis of minus I power. See. This is the group attached with the carbon chain. Attached with the carbon chain. Attached with the carbon chain, right? Carbon double bond oxygen. Oxygen being electronegative negative, so this carbon is having delta positive. This carbon is attached with nitrogen, so this carbon will have delta positive, right? As simple as that. Now have a look. Positive charge is already present on this carbon, delta positive, due to electronegativity difference between carbon and oxygen. Over here again you have got positive charge on carbon due to electronegativity difference. Wherever intensity of positive charge is more, that is going to be more electronegative. So if I talk about this carbon and this carbon, which has got more intensity of positive charge, this carbon is attached with oxygen, right? Oxygen would have dragged the electrons towards it, sigma electrons towards itself, or I'll say oxygen would have dragged the bonded pair of electron towards itself, right? Due to which the intensity of positive charge on this carbon is more. If the intensity of positive charge on this carbon is more, right, that means it is going to drag more sigma electrons from the chain towards itself, due to which this group shows more minus I, followed by this group, then followed by the last one, right? Over here there is no charge on this carbon, right? That's why I give the least priority to the last one, okay? NF3 positive, NH3 positive. Where is the intensity of positive charge more on nitrogen? Over here nitrogen is attached with fluorine, right? So minus I power, right? Nitrogen positive charge, phosphorus positive, arsenic positive, antimony positive. Positive charge on an electronegative element makes it more electronegative. So this nitrogen being more electronegative as compared to this phosphorus, as compared to this arsenic, as compared to this antimony, right? More electronegativity means more is going to be the power of this group to drag the sigma electrons from this carbon chain towards itself. So this is going to be the minus I power, right? Yes? Right, people? Same is the reason for this one. Same is the reason for this one. Correct? More electronegative element is having positive charge. Positive charge on an electronegative element makes it more electronegative. Right? What about the last one? What about the last one? Do let me know the answer of last one in the comment section afterwards, right? This is going to be your homework. This is going to be your homework. Do let me know the minus I power, the minus I power. Do compare the two, right? Do compare the two and let me know their minus I power in the comment section afterwards, okay? I'll be exactly checking it out, what you guys will be answering, right? Okay, let's move on. This is basically the minus I series which I would want you guys to remember, right? NF3 positive will be having maximum minus I power, followed by NR3 positive, followed by NH3 positive, followed by NO2, followed by CN, right? This is the minus I series which you need to remember first of all. And in the similar way, this is the plus I series which you guys will be remembering for different groups or atoms, right? Minus I series and plus I series, this is really important. So do remember this series at any cost, right? Okay. And as I told you, both plus I and minus I effect are considered up to only 3 carbon atoms, right? Due to which inductive effect is considered as the weak effect because it diminishes after 3 carbon atoms. After 3 carbon atoms, we do not take its effect, right? That's why this inductive effect is considered as the weak effect compared to the other electron displacement effects, right? Okay, perfect. Arrange the following according to their stability order, right? These are the carbocations which are given to us and carbanions which are given to us, right? We need to arrange these carbocations on the basis of their stability, right? Well, stability of the carbocation is decided by hyperconjugation generally, right? But since we have studied only inductive effect, so I want you to solve these questions on the basis of inductive effect. You can solve this on the basis of hyperconjugation as well, right? We know that, correct? But I want you guys to solve these questions on the basis of inductive effect because we are only done with inductive effect yet, right? See now. See guys. This carbon is having positive charge, this carbon positive, this carbon positive, this carbon positive charge, right? More the charge on the species, more its potential energy, less its stability, right? Less the charge on the species, less its potential energy, more its stability, right? So indirectly I can say more the charge, less the stability. Be it positive charge or negative charge. More the charge, less the stability, right? Over here carbon is attached with 3 hydrogen atoms. Over here carbon on one side is attached with CH3. Over here on 2 sides CH3. Over here on 3 sides CH3. CH3, all the alkyl groups, they show plus I. So where is the plus I more? Plus I is maximum in the last case. If plus I is the maximum in the last case, what plus I groups do? They push the sigma electron density. So on 3 sides, electron density is being pushed towards this carbon, due to which the magnitude of positive charge on this carbon would have suppressed, would have got decreased, right? Yes, the magnitude of positive charge on this carbon would have got decreased as compared to this carbon, as compared to this carbon, as compared to this carbon, right? And wherever magnitude of positive charge will be less, stability is more. So this is the stability order. Simple, right? Similarly, see, this carbon carrying negative charge, this carbon negative, right? Over here you have got, on 3 sides you have got alkyl groups, on 2 sides you have got alkyl groups, on 1 side you have got alkyl groups. And all the alkyl groups, what do? They show plus I effect, right? So on 3 sides you are getting plus I over here, right? What this plus I group is going to do? It's going to increase the sigma electron density towards this carbon, due to which this was already negatively charged. Due to which negative charge on this carbon will be maximum, right? As compared to this, right? More the charge, less the stability. So which one is going to be more stable? This one, followed by this one, followed by this one. Isn't it simple, my dear people? Isn't it simple? Yeah? Let me know fast in the chats if it is clear. Right? Okay. Arrange the following according to their stability order. We have got positive charge on this carbon. Right here we have got positive charge on this carbon, positive charge on this carbon, right? So have a look. Positive charge on this carbon. This alkyl group is going to show plus I effect, right? This carbon is having positive charge. So on this side there is an alkyl group which shows plus I. On this side also it will be getting some sigma electrons. From this side also it will be getting some sigma electrons, right? On 2 sides it will be getting the sigma electrons, right? So where will be the intensity of positive charge minimum? Can I say intensity of positive charge is minimum on this carbon, followed by this carbon, followed by this carbon, right? And wherever charge is minimum, stability is maximum. So 2 is maximum stable, followed by 3, followed by 1, right? More the charge, less the stability. Less the charge, more the stability. Simple. CH3 positive, CH2D positive, CHD2 positive, CD3 positive. Few minutes back only I told you, protium, deuterium and tritium, they show plus I power, and this is the plus I power of them, right? So do remember, deuterium has got more plus I power as compared to protium, right? So where are the deuterium maximum? Over here deuterium are maximum. If deuterium are maximum in this case, right? So the intensity of positive charge on this carbon will be minimum, right? If the intensity of positive charge on this carbon is minimum, so its stability is maximum, right? Its stability is maximum, correct? Over here, carbon carrying positive, this carbon carrying positive, this carbon carrying positive, right? NO2 attached, CN attached, F attached. Few minutes back, I gave you one series. As I told you, minus I power of NO2 is greater than that of minus I power of CN, which is greater than that of minus I power of F, right? So what these groups are going to do? These groups are going to pull the sigma electrons towards itself, due to which the magnitude of positive charge on this carbon will be maximum, because this group is having maximum minus I power, followed by this one, followed by this one, right? So where is the magnitude of positive charge more? Over here. More the charge, less the stability. So this is the stability order, right? This is the stability order. Okay? Let's talk about these two as well. Arrange the following according to their acidic strength, right? We are going to arrange them on the basis of their acidic strengths, right? Yes. As we have seen, acidic strength of the acid, it depends on the stability of the conjugate base. More stable the conjugate base, stronger is going to be the acid, right? More stable the conjugate base, stronger is going to be the acid. So first of all, we are going to make their conjugate bases. How do we make their conjugate bases? Just replace this hydrogen and over here put a negative charge. Replace this hydrogen, over here put a negative charge. So we got the conjugate bases. Now check their stability. Check their stability. So over here fluorine is attached with the second carbon. Over here fluorine is attached with the third carbon. Closer the fluorine, more its minus I power. Closer the fluorine, I must say like, I'll say it like this. Closer the fluorine, right? I'll say over here, negative charge, the intensity of the negative charge will be less as compared to the intensity of negative charge over here. Why? Because this electron withdrawing group is closer towards negative charge. Electron withdrawing group is closer towards the negative charge, right? Yes, so intensity of negative charge on this oxygen will be less. If intensity of negative charge over here is less, right? So I'll say this conjugate base is more stable, right? This conjugate base is more stable. Less the charge, more the stability. More the stability of the conjugate base, more is going to be the strength of the acid, right? So this is going to be the acidic strength, correct? What about these? What about these? Take the H positive out, this is the conjugate base, right? Take the H positive out, this is the conjugate base. Take the H positive out, this is the conjugate base. Take the H positive out, conjugate base, right? Okay. This group is under maximum angular strain, right? This group is under maximum angular strain. Okay. So if I compare the electronegativity of this group, this group, this group, and this group, where will be the electronegativity more? Or I can say it like this. What about the electronegativity of this carbon, this carbon, this carbon, and this carbon? I must say electronegativity of this carbon is more, right? We have discussed this in the last session. If electronegativity of this carbon is more, right? So this carbon is going to decrease this negative charge to the maximum. So negative charge will be the least over here in the first one as compared to this, as compared to this, as compared to this. If negative charge is least in this one, so conjugate base over here is going to be more stable, and more the stability of the conjugate base, same is going to be the order of the acidic strength. So this is the order of the acidic strength, as simple as that, right? Clear to everyone? You guys can let me know in the chats if it is clear to every single guy, my dear people, fast. Yeah? Let me know fast. Perfect? Okay. Alright, arrange the following according to their basic strength, right? How do we compare the basic strength? Any substance which has got the tendency to donate a pair of electrons. Any substance which has got the tendency to donate a pair of electrons, it acts like a base. It acts like a base. See, this nitrogen has got the lone pair, this nitrogen has got the lone pair, right? Okay. So wherever nitrogen will be having more tendency to donate the pair of electron, among the two, that nitrogen which has got more tendency to donate the lone pair, that's going to be more basic. Then only it's going to be more basic. Have a look. This nitrogen is sp3 hybridized, right? This is S, this is P, and this is 3, right? This nitrogen, it is sp2 hybridized. Okay, this nitrogen is sp2 hybridized. S character of this nitrogen is more. Electronegativity of this nitrogen is more. If electronegativity of this nitrogen is more, that means this nitrogen is going to hold its lone pair firmly as compared to this nitrogen. So where is the lone pair more available to donate? Over here, lone pair is more available to donate. And wherever lone pair is more available to donate, their only basic strength will be more, right? Simple. This nitrogen has got the lone pair, this nitrogen has got the lone pair, correct? So where will be the lone pair more available? I'll say lone pair is available more in the first case, because over here you have got chlorine, over here fluorine. Fluorine is more electron withdrawing, right? Yes, the availability of lone pair over here is more, due to which it's going to be more basic as compared to this, right? Yes? Right, people? This is again going to be your homework. Do let me know the basic strength over here. Do let me know the basic strength order in the comment section, right? Okay. So people, I think this much is enough for today, right? This was all about the inductive effect. I'm sure you would have enjoyed the session. And the ones who have not joined the JEE 2022 batch on the actual Vedantu platform yet, do get enrolled as soon as possible. You can take the subscriptions for 15 days, right? To just see the batches, to just see the teachers, right? To just see whether you are getting benefit out of the sessions or not, right? Just take any one of these plans, get enrolled to the actual Vedantu platform, right? Get enrolled to the batch which has started on the actual Vedantu platform, right? For the ones who are going to write the JEE in 2022, right, people? And if you're using this coupon code WSPRO, WBPRO, you'll be getting some additional 10% off, right? And all these codes are perfectly affordable at the same time. The ones who are going to write the JEE in 2023, you guys can enroll in your batch by taking any of these plans, right? You can check these plans for 15 days first, then you can go to the actual classroom program, right? Okay, there's a link in the description box of the video. Do click on that link, right? Get added to the Telegram group and stay updated about the classes. And the ones who have not liked the video yet, please and please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So do like the video, share the video with friends, and do subscribe to the channel as well. So with this, I'm going to take a leave. Let me see you guys tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.